All right, welcome back to the Explainer. Have you ever typed a question to an AI, gotten a response, and just thought to yourself, what is really going on behind the screen? Well, today we're going to do just that. We're pulling back the curtain to demystify the large language model.
I mean, it's a feeling we all know, right? You type something in, and what you get back, it feels like magic, doesn't it? But, it's not magic. It's this incredibly fascinating, totally invisible process. And that's what we're going to do. We're going to follow that journey, step by step, to see what is actually happening inside that black box.
Okay, so before we can really follow our prompt on its journey into the machine, we kind of need to understand the machine itself, right? So let's just get right to it, the big answer first. What exactly is a large language model, or LLM?
Okay, here it is, the big definition. A large language model, or LLM, is an AI system that's been trained on just vast amounts of text data. And its whole job is to understand and generate text that sounds like a human wrote it. And listen, pretty much every word in that definition is doing some heavy lifting. It's packed with meaning. So let's break it down.
All right, so first up, AI system. That's pretty straightforward. It's just a really sophisticated program that's designed to mimic intelligent behavior. But this next part, vast text data, whoa, that is a serious understatement. I mean, we are talking about a library of books, articles, websites, so huge it's almost impossible to wrap your head around it. And the whole point of all that, this massive effort, is just to achieve human-like text, to talk to us in a way that feels completely natural and coherent.
All right, so you've given this machine access to pretty much the entire internet and then some. But how does it learn from all that data? The best way to think about it is like a super fast, super intense school for a digital brain. This is what we call the training process, and it's absolutely crucial.
So this all happens in a phase called pre-training. Step one, it just ingests all that data. It basically speed reads everything we've ever written. Then, step two, it starts to identify patterns. And we're not just talking about facts. It's learning the deep structure of our language. Grammar, syntax, even different styles of reasoning. And then comes the final, huge leap. Step three, it starts to master context. This is where it learns that incredibly complex web of relationships between words. And that is where meaning really comes from.
Okay, so our model is trained. It's ready to go. So let's get back to our question. What happens the moment you type something in and hit enter? Your words, they're about to take a little trip deep inside the machine. So to make this easy, let's follow a really simple sentence on its journey. The model learns patterns. Just 4 words and a period. Simple, right? To you and me, that's just a statement. But to the LLM, that's a stream of data that needs to be completely taken apart.
So the very instant you hit enter, the first thing that happens is something called tokenization. See, the AI doesn't see words the way we do. It sees tokens. It just chops up your sentence into the smallest possible units that it can actually process. You can think of it as the very first step in translating our language into machine language.
Okay, so after it's been chopped up into tokens, the next step is called embeddings. And honestly, this is where things get really cool. Each of those little tokens gets turned into a long list of numbers. It's called a vector. And this vector is basically a mathematical fingerprint for that word's meaning. And it's not random at all. These numbers place the word in this giant, multidimensional map of meaning. You can even do math with them. It's wild. If you take the vector for king, subtract the vector for men, and add the vector for woman, you mathematically land right on the vector for queen. That's how it understands relationships.
Okay, so our prompt has been tokenized and then turned into these meaningful numbers. Now, we enter the real engine room of the LLM. This is something called the transformer architecture, and it has a superpower. It's a concept called the self-attention mechanism. And this right here is what lets the model actually think about the full context of what you've asked. And this is where the AI's way of reading is completely different from how we do it. When we read a sentence, right, we kind of skim it. We focus on the important words, the nouns, the verbs, to get the main idea. But the self-attention mechanism, it's obsessive. It mathematically scores the importance of every word in your prompt against every other word in your prompt. This is how it's able to figure out that in a sentence like, the bee landed on the flower because it wanted nectar, that it refers to the bee, not the flower. It's an incredible way to capture the full context.
Okay, let's recap. We've taken our sentence, we've tokenized it, we've turned it into numerical embeddings, and we've run it through this incredibly powerful attention mechanism. It has analyzed our request from every possible angle. But why? What is the one single goal of all of this massive computational effort?
So yeah, after all that, the tokenizing, the embeddings, that wild self-attention thing, what is the one simple thing it's trying to do?
And the answer is surprisingly simple. Its entire job is just to predict the next word. That's it. All of that complex machinery, all that processing, it exists for one reason: to make the best possible statistical guess for what word should come next in the sequence. And then it adds that word to the sentence, and it does the entire thing over again for the next word, and the next, and the next. It generates its response one single word at a time. It's basically the most sophisticated, most advanced autocomplete you've ever seen. So when you boil it all down, it's just an incredibly sophisticated prediction machine. And that leaves us with a really fascinating and maybe kind of unsettling final question. If all it's doing is just predicting the next word based on a whole bunch of math and statistics, is it truly understanding anything? Or is it just the most convincing mimic we've ever created? It's definitely something to think about. Thanks for joining me on this explainer.